Hello and welcome back. Today we will continue the chapter of differential equation. Now I am going for the methods of solution of differential equation. Okay. So our first method is method of solution of differential equation by separation of variables. Right? Separation of variables. So let's discuss at first the idea behind this method. So there is a differential equation. Let me say it is x dy equals to y dx, right? So what we can do is we can shift y to the right side and shift x to the we can shift y to the left side and shift x to the right side. Hence, what we are getting is dy by y and dx by x. But to the left, there is everything which belongs to y only, and to the right, there is everything which belongs to x only. Right? But the variables have been separated fully. No x is there in LHS and no y is there in RHS. This is the idea behind the method of differential method of solution of differential equation by separation of variables, right? So in generally I can write it like fx dx equals to fy dy. If I can change a differential equation in this form, then I can use that method of separation of variables, right? This is the idea. So we'll do 3-4 sums to understand this idea, right? And after that, in some other classes, we'll discuss methods of homogeneous functions and all, integrating factors, okay? So now we're going for the sums, okay? Let's go. Okay, so that's our first sum, which is x e to the power 2y plus 1 dx by e to the power y equals to dy. So at first we will separate the variables. So how to separate? We'll keep x to the left and we'll take the variables or everything that belongs to y to the right. So it will be e to the power y by e to the power 2y plus 1 dy. So what we can see now that x is to the left and y is to the right. Now we'll integrate. Integrating both sides, integrating x dx, integrating e to the power y and e to the power 2y plus 1 dy. Integration of x dx is very easy, it will be x square by 2, but that e to the power y 2y, we have to substitute. Let e to the power y equals to m, then dm equals to e to the power y dy, dm equals to e to the power y dy, right? So e to the power y dy. So we'll write dm by, and we have taken e to the power y as m, so it will be m square plus 1. So integration m square plus 1. So what we are getting is x square by 2 equals to dm by m square plus 1. So that is a like definite form of special form of integration, which is tan inverse m plus c. C is constant of integration, right? Because it is an indefinite integral. So x square by 2 equals to tan inverse m. Now we assumed m as e to the power y, so tan inverse e to the power y plus c. So that is the first sum of methods of separation of variables, right? So you have to know integration very well, obviously, to solve differential equation, right? So now let's move to the next sum. Okay, so that is our next sum of differential equation. So let's separate the variables and then integrate, right? So we'll take x to the left and y to the right. So no, sorry, we will take y to the left and x to the right. Okay, so log y dy will take y to the left, log y by y equals to cos x minus sin x by sin x plus cos x dx, right? So again we have to substitute, right? Else the sum will not be integrated. So we'll take, let's start at first integrate. Integration log y by y dy integration cos x minus sin x by sin x plus cos x dx. So let log y equals to z. So dz equals to 1 by y dy. Okay. So 1 by y. So it will be 1 by y dy. So log I z. So z dz, right? And the next sin x plus cos x. Let sin x plus cos x equals to z. Sorry, zm. Okay. So let m equals to sin x plus cos x. So dm equals to cos x minus sin x dx, right? So dm equals to cos x minus sin x dx. So cos x minus sin x dx. So dm, and that will be m. So integration z dz is z square by 2 equals to dm by m equals to log m plus c, right? Log m plus c. Now you know that in calculus that log ln is written because by default the base is e. So next we'll substitute z, right? Z we take log y, so that will be log y by 2 whole square, and in place of m we'll write sin x plus cos x plus c, right? That is the solution of that differential equation, right? So that's how we do the solution of equation by separation of variables. So this is the way only. We have to separate x and y, and then we'll like solve in different methods of integration, right? So this is the method of solution of differential equation by separation of variables. In the next class, we'll meet with a new process of differential equation, right? See you then. Bye.